Hey guys, we're going to talk about exponents today. So just want to remind you what an exponent is. We've got some number or letter raised to a power, some number or letter. In this case, I'm using both letters. I have a to the m power. A is our base and m is our exponent. For example, 4 to the third power really means big equal sign. 4 times 4 times 4. This exponent part tells you how many of the base that you have, and you're always multiplying those values. So 4 times 4 times 4. If you had 7 to the 6th power, that would be 7 multiplied by itself 6 times. And no reason to know the value of that. I'm just telling you that 4 cubed is 64, just to remind you that these do multiply. 4 times 4 is 16, and 16 times 4 is 64. Now, what we're going to be working with, you're not going to need to evaluate unless it's a smaller number. So let's not worry about evaluating. We're going to keep our answers looking like 4 cubed. And here's exactly what I mean. So starting with number 1, you will have, and the directions say multiply. So please get that down. Multiply. Number 1, 2 to the 4th power. This means times 2 to the 3rd power. So I have 2 to the 4th. 2 to the 4th times 2 to the 3rd power. Well, 2 to the 4th, I know that one, right? Just like 4 cubed, I knew that one too. 2 to the 4th power is in green here. It's how many 2's do I have? I got 4 of them. 1, 2, 3, 4. So I have 2 times 2 times 2 times 2 times 2 to the 3rd power. I know that one too. It's in blue here. 2 times 2 times 2. There's 3 2's. Now all together, when I have 2 to the 4th times 2 to the 3rd, I have 4 2's times 3 2's. So how many 2's do I have all together? 1, 2, 3, 4, 5, 6, 7 2's. So my answer for 2 to the 4th times 2 to the 3rd is 2 to the 7th power. Now let's think about that. How did I get that answer? 2 to the 4th times 2 to the 3rd. How do I get 2 to the 7th? Like, is there anything we can do with those numbers? And that's what we want to think about. Or look right here. Hint, hint. All right, let's see it with our variable here. And remember, I said the base can be anything. It can be a number. It can be a variable. So for number 2, I've got x to the 5th power times x to the 8th power. So first thing is x to the 5th power. How many x's do I have? I have 5 of them. X times x times x times x times x. So this is the, in green, those 5 x's. And then I have x to the 8th power, so how many x's am I going to write in blue? 8 of them. So times x 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 times x. So total, how many x's do I have? So I'm going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if you want to do this every single time, you can totally do that. Or what did we do to get 13? I have x to the 5th times x to the 8th. Just add these numbers. So it's x to the 13th. Adding them. So here's my rule. When multiplying with, that W slash means with, I'm sure you knew that. So the rule, when multiplying with the same base, notice the base is 2, and notice the base is x. So they have the same base. I don't really have much room to underline that same, but make sure that it's the same base. Base, remember, is whatever that is. The 2 is the base and the x is the base. You must keep the base the same, and it says add exponents. So again, I didn't turn this into a 4, 6, or an 8, or whatever you want to do, and I see some crazy things. Don't do that. You keep the base the same, and you're adding your exponents. 4 plus 3 is 7, yeah. And here, keep the base the same. It's just an x, and 5 plus 8 is 13. So when multiplying with the same base, keep the base and add the exponents. All right, cool. Let's practice.